Assalamualaikum warahmatullahi wabarakatuh. Good day, ladies and gentlemen. My name is Arfie Ikhsan Firmansyah. At this time, I will be presented our research with the title Design of Ocean Current Blade Turbine 100 kilowatt using Hydrodynamics Simulation Approach. Background of the research. First is the supply and demand electricity. That is the half gap from the supply and demand. The demand side is constantly grow. That is 6.4% per year in 2021. Other side, primary energy for the electricity in Indonesia has been decreased. The reserve of so-called, it is the primary of fuel power generation in Indonesia. Because that energy diversification, especially for renewable energy, must explore to reduce the gap. Indonesia have the potential renewable energy from the ocean energy because it's 63% region of Indonesia is ocean. Ocean have many energy to conversion electricity. One of is ocean current power generation. Based data from the Ministry of Energy and Mineral Resources, electricity will be produced 18 gigawatt from the conversion of reserves of ocean energy. Turbine is the one of the primary component of the power generation. There are two types, horizontal and vertical axis turbine. The optimal turbine blade design will be high compression kinetic energy from the ocean current, which produce torque to turn generator for the produce electricity. The result study will use data from Ralantuka Street that have been chosen from the provision study. The turbine blade design is expected in the ocean current characteristic in Ralantuka Street. The methodology of the study has shown in the flowchart. The first step is designing blade turbine that have two models. One of the model is the redrawing existing vertical axis turbine. Next step is the create model ocean current and geometry in computational fluid dynamic or CFD. After that is created this iteration boundary parameter and goal of simulation using analysis tool software. Next step is the processing solve from the tool. If the result is convergent, the result of existing will be verification with experimental data. The verification data criteria is below 5% error from the experiment data. That must have same trend. The final step is post-processing. The verified parameter in the existing model will use to design of the blade turbine. This slide shows the redrawing ocean power generation in the right side. The geometry has used the verification result, the analysis using CFD, because the ocean turbine existing have the experimental data. At this slide, so the verification data from simulation and data from the experimental, which has standard error below 5% with the experiment and simulation data. After have the parameter verified, the parameter design is decided. It is the consist of the rated capacity, rated cut in, cut out, and solvable current speed for design ocean current turbine. Horizontal axis turbine has chosen that turbine is in the Ralantuka Street due a rated capacity and condition of site. The next is determination of the number of blade it has used to speed ratio equation or TSR. The TSR value is 5 for this case. compare with table in the right side, the amount of blade we decided is 3. After this choosing and creating geometry model of NACA or hydrofoil, it has chosen the NACA 0016 because NACA 0016 is suitable for the ocean current turbine. The drawing geometry model. Next step is the determination of the segmentation of its twist on the blade, inclination angle, or twist and cut length. After the geometry has been created, the simulation using CFD has started. On the slide, in the left is the geometry of blade, and the right side is the trajectory of ocean velocity, show of flow trajectory, and the pressure value on the blade. This slide is on the variation of the simulation different ocean current speed and RPM. From table, the turbine design could be created power to turn generator to create electricity to ocean cut-in speed as low as 0.3 meter per second and 2.2 meter per second to have the rotor power generator to achieve design capacity of 100 kilowatt. Finally, computer fluid dynamics was used to design the turbine with the 100 kilowatt horizontal axis turbine capacity. The finding demonstrate that the design of the turbine could generate power to produce electricity at low ocean current speed or cut-in speed of 0.3 meter per second, and that rotor power generated at the ocean current speed of the 2.2 meter per second achieve the design capacity of 100 kilowatt. Thank you for your kind attention. Wassalamualaikum warahmatullahi wabarakatuh. Okay.